Hello, this is Eaton Donald, CEO of Tri-D Technologies, makers of ExactFlat, the leading program for 3D to 2D digital patterning. And today we're going to demonstrate taking in a dress, which was modeled in Optitex 3D. Here you can see the dress and the avatar modeled on an avatar in A pose. And we're going to apply various textures to this dress, flatten those textures and patterns, and create two-dimensional patterns for printing on a digital printer, such as an EFI Reggiani printer, and for cutting on a cutting table, and then eventually making a garment. The purpose of this demonstration is to show you the power of ExactFlat and the power of the digital textile printing opportunity. Mark, if you could please start the process by maybe getting rid of the avatar and just let's focus on the dress. And then we can texture map the dress, applying various textures to it, flatten it, and then we can show the process of changing it.
Sure, Eaton. So I have the dress here without the avatar.
Okay.
You can see this here. It comes in as a single surface or a single surface. So the first step we would do is explode the mesh, the dress mesh, just by rectangle selecting, and I'll hit enter on my keyboard. And now what you'll see is that this dress is actually all the individual pieces.
And we should point out, Mark, that this is not the design phase here. This is the pattern engineering phase. Is that correct?
Yes, the design phase would have been done with the Optitex model using their avatar and drawing the dress on the avatar. So this is basically after that's been done.
Okay, so we just want to make that distinction very clear, that there's really two phases here. There's a conceptual design, which is designed for aesthetic review, designed for sales, designed for approval, designed for a whole variety of other things. And once those things are completed, then you're going to go through a preparation for manufacturing. And this is where ExactFlat sits. ExactFlat is the intersection of the inspirational creativity in design and the engineering, which follows the approved designs that have to be moved into manufacturing. All right, Mark, go ahead and continue, please.
Okay, so another thing that we can do is actually change the texture. So I can go in and I can select the texture for the dress simply by clicking this bottom color, which will change textures by going through my library and selecting, say, a paisley pattern. I'll just hit OK here. And if we go into our render mode, we can see the paisley pattern, or I could change that by selecting the dress again, just highlighting everything, going into the library, and we'll pick maybe a different print. So if I go down here, we can go into my library and say select this pattern here. Just hit OK. And now we have that checkerboard pattern. So
let's just stop there for a second, Mark, if I could, because we have to kind of talk about this a little bit. The patterns you're putting on here this is an alternative way to create a graphical design on a dress. So typically people use pre-printed fabrics. And with those, they would run the patterns, make the patterns, and then cut the patterns on a roll of pre-printed fabric. Now, we're not doing that right now. We're applying a texture to the fabric. And then what are we going to do after these textures are made?
After that, we would simply flatten the dress with the texture on it. So ExactFlat Monarch has the capability of taking a graphic and flattening it based on the characteristics of the material. So when it's rewrapped, there's no seams, so there'll be seamless, the texture will be seamless across the seams. So in this case, these cubic squares where the seam would be cut, say if it intersected a square, you would be able to match those two pieces. We can show that visually very easily.
Okay, let's go back to that to the let's put maybe a different pattern on here, maybe the network texture pattern, for example, and then let's go through the process. So if I understood you correctly, we can map a texture onto the 3D object, and when we manufacture that, the texture will flow and match seamlessly across the seam boundaries. Is that correct?
Yeah, that's absolutely correct.
So
So
you don't have to do traditional flow matching. And the beauty here is you can see how fast it is to change a texture. So if you wanted to make a collection or variations, design one style of dress and then have a lot of different color patterns and so on, you can do it in just a few minutes.
exactly. So the next step here, Eaton, would be to flatten the dress. And I'm actually going to go back into the wireframe. And what we'll do is go to our next tool. We'll hit our tool tab and we'll select our flattener, which is the first icon. Again, we just rectangle select the dress and then we'll hit enter on our keyboard. And I'll go back into my layers. And we have now ExactFlat pattern layer, which has just been created. So I'm going to make that view active and I'll turn off the other two, the model and default view. We'll go into our top view. I'll just zoom in. And if I go into my shaded view, you can see that there's a stress. This is actually projecting a stress map onto the pattern pieces. So ExactFlat is a two-stage flattener. So the first stage is giving a projected flat. And one thing I'll point out is here, these hash marks or little X's that go down the side are indicating to me that there's material flipped over on itself, and you can kind of see that edge there. We have what we call pre-flattening tools, and I'm going to use one called a fracture tool, and I'll simply click the piece and you can see it takes out those flip triangles. So if I go
So
through,
those flip triangles would, in the real world, be seen as wrinkles. Is that correct?
yeah, wrinkles, or if you had a piece of material fabric and you just flipped it over on itself, so there's an edge that's kind of underneath the main part of the material.
So that would be a fold. It would be folded over.
Exactly.
Okay, so by this process then is just to eliminate those folds in preparation for the optimized flattening process.
Exactly. So once we have it here, we would simply go to our next step, which is go to the next icon, which is our optimize tool, or I call it the spring tool. We'll select that and we'll just go through, select the pieces we want optimize, which is all the pieces. And once we have them all optimized, we would simply hit our enter on our keyboard. This brings us into a material setting dialog. So we can browse a list of materials. For instance, right now we're using cotton, which I'll just say, yeah, we want to use cotton. So it's going to actually take the physical characteristics of cotton, apply it to the flat piece, and actually optimize it based on the material properties or characteristics of cotton. Once I've done that, I just hit OK here, and I'll move this screen over so you can see once the algorithms start running, you'll be able to see that the material actually, as you can see here, the strain and the stress is coming out of the fabric.
So the optimizer then is searching for areas of strain and sag.
Yes.
And it is redrawing the pattern piece in such a way that it minimizes the strain and minimizes the sag. Is that how this is working?
Exactly. So in this piece here that have my cursor over, this black area shows a significant amount of sag in the material. So when the optimizer gets to this piece, you'll notice that it'll work that sag out of the pattern piece.
So typically the 3D virtual prototyping software that's in the marketplace today would create a virtual prototype that would be used to create a virtual sample. The virtual sample would then be used to get approvals or design reviews or some other aspect in the decision-making process. But the problem is those virtual samples or those virtual prototypes would be the end of the road. You would need to create a physical prototype by actually creating this garment physically before you got your pattern pieces. Now that's the traditional process. Describe again the workflow here in the new digital 3D to 2D patterning process.
All right, Eaton. So in the digital patterning process, what we would be doing is consuming or taking in the file from Optitex or a design tool that's giving a simulated 3D, bring that into ExactFlat Monarch, texture map it. So we'll take a texture or a graphic that we want to apply it to the dress in this case, flatten the dress in a way that it simulates the actual flattening. In this case, I'm using cotton. So I'll go through and create a flat pattern based on cotton. And then once that's done, we'll turn the graphic back on, and the graphic will actually have stretched or matched when we lay all the pattern pieces out together. When you sew it, you'll see that the graphic is seamlessly flows across the whole dress, across the seams.
Okay. Now let's talk a little bit while this is flattening or while this is optimizing, the pattern pieces are optimizing. Let's talk a little bit about what you need to do this. So first of all, I want to ask you about your computer. What type of computer are you running? Is this anything special that you're running right now?
This is a laptop that was purchased at Best Buy. It's a typical laptop. It's a Dell laptop. The one thing that I have in the laptop is a GeForce NVIDIA graphics card, which is what I would suggest to run the software.
Okay.
So any laptop.
Sorry, Mark, go ahead.
No, I was just going to say any laptop, but NVIDIA has a graphics card, so the graphics processor is important because we're doing texture mapping, and it's good to have a good graphics card.
But this laptop is not anything special if you're buying it at Best Buy. It's certainly not a traditional CAD workstation.
No, exactly. It's if you want to call it a gamer laptop, it's about $1,000.
Okay, so if you were running this on a professional business class CAD workstation, the time required to go through this process would be significantly faster.
Yeah, exactly. If I had a desktop system and I was using it, it would be already done by now, probably.
Okay, all right. So it looks like it's running at about a minute to 2 minutes per pattern piece. Mm-hmm. Certainly, compared to manual pattern making, this is a lot faster. Let's talk a little bit about the digital printing opportunity while we are waiting for this to complete. So digital textile printers are relatively new to the mainstream, but that just means they're going mainstream. They've been around for some time. And what they offer is the ability to manufacture garments with specifically designed graphics that are compelling consumer designs and compelling from a sales and a fashion perspective at production runs, which are very short, as little as one dress. How much would this dress cost if you have run it through, designed it, run it through ExactFlat, create the patterns, cut it, sewn it, and it's ready to put on the fit model?
So the cost, from the Optitex model, flattening it, and sending it to the digital printer, the total time in our software and printing was about 2 hours. So
and that 2 hours was mostly scheduling at the printer, correct?
Yeah, exactly. So whatever time it's taking here, as you said, it's probably a minute or 2 minutes a piece. We have 8 pieces, so say that's 8 to 10 minutes for flattening. And then the printing itself was about an hour and about 20 minutes to sew it together. So let's say 2 hours round trip.
So if, for example, you had a business model where you merchandised your fashions online. People bought it and paid for it. And when they did that, that triggered the manufacturing order. So instead of making all of your inventory in advance
Hmm.
and tying up all of this capital in work in progress or inventory in progress, you could actually trigger the manufacturing order when the garment is purchased, and you could still have it out the same day.
Yeah, exactly. Exactly.
Okay, let's talk a little bit about what's happening now to these pattern pieces, because we can see that there's little colors here. Can you just explain the color code that we see in the screen?
Yeah, sure. So going back to this, remember about 80% of this piece was black. That was showing sag. In this case now, it's gotten rid of most of the sag except this area right here, which on both pieces kind of match, which is good. Um, so there's a little sag here. The red areas here indicate high levels of strain, so about 20% strain. But I don't believe we've gotten to these pieces here yet. This piece here, I can tell you right now, I just noticed that there's a triangle that's right in the center here. So I'm going to fix this piece in a second. Um, and you'll notice when you're running the optimizer, if it gets to about 10% and it just stops, you probably have material that's flipped over on itself. And we have a tool, and I'll show you that in a second, which will take care of triangles that you can't see, because it's probably right here where the sag map is, and because the indicator would be black, you can't really see it. But I could tell when the process slowed down.
And Mark, this is because you've been doing this for some time now. In fact, you're probably the world's leading expert in 3D to 2D digital patterning. You've had one foot in the 2D world and one foot in the 3D world for more than a decade now. And I would say that you've probably seen more models and flattened more models than anyone on the planet. So we can certainly appreciate your sharp eye in spotting these things. I'm interested to see how you fix it. So how are you going to fix this piece?
Okay, so we'll just once we get through to these last two pieces, we'll go back to that one piece,
So
and
that's
I'll
piece
show
number
you.
5. Okay, yeah.
Yeah, it's this piece right here. So I think it's actually piece number 1. I'll show you in a second that when we flatten the pieces from the 3D model, we have in our highlights toolbar, which I haven't shown yet, we have the ability to turn on and off or toggle on and off like a numeric numbering system. So actually have numbers assigned to each one of these pieces. I'll show you that in a second. But as I said, if I just we'll stop this. And this is the piece right here that I believe we have a problem with. So what we're going to do here is I'm just going to move this over here. I'll just click OK. And I'm going to go use this tool here, which is a triangle remover. And you can see there's quite a few triangles that were bad in that case. This is called a flip triangle remover tool. And it's great if you have under 20 flip triangles. And as I said, those flip triangles are right here. I couldn't see them with my eye, but when I saw that the optimizer had stopped at 10% on this piece, I realized there was something wrong. Let's go back in. I just want to show you, if I go into wireframe and I go into my highlights, I can turn on, you can see right here, the number.
Piece numbers, yes. Yep.
Yeah, so that actually kind of gives you a good indication. If I was doing a drawing, it would show me which pieces are which. So let's go back in here into our shaded view, and we'll just finish the process of springing this this piece here. And I believe there was one other piece, which is probably this part here. And we'll just finish off those last two pieces real quick.
And so, Mark, just as people are watching here, I do want to point out that the expectation for ExactFlat users is not that you are a fashion designer. This is not software that fashion designers are going to come in and design their compelling designs. This is a a 3D to 2D digital pattern making software. And right now, if you're sending your designs to overseas locations, or if you've got pattern makers, this is the software that they would use to create the patterns. Or you may be outsourcing your pattern making right now, and you may want to bring it back in-house for a variety of reasons. This is the software you use to do that. And so this would typically go out to a 2D CAD program when these patterns are complete for finishing, correct?
Right. Yeah. So basically, we're just going through the process we showed today was using the Optitex tool with a 3D avatar, bringing that dress into ExactFlat Monarch, flattening it, and in a second, we're going to show the texture map again on the 2D pieces, and then we're going to use what we call a find tool to find where all the pieces go, and that way we can we'll be able to zoom in and show how all the graphics line up.
And I can see that piece now, number 2, those red speckled areas along the seam where it indicated all the strain, those are now being optimized and they've been removed.
Yeah, exactly. So, just visually looking at this, this is a totally manufacturable dress. As you can see up here, we're at about 80%, and we're working on this part here.
And one thing I do want to try when we're finished is because there's a lot of 3D to 2D flattening technology in the marketplace, or at least that claims to be 3D to 2D flat pattern making technology. So I'd like to, before we finish here, I'd like you to measure the surface area of any one of these pieces, say piece number 6 and piece number 2, in 3D, and it will measure the surface area of those pieces in 2D, and we'll see what the variation is.
Okay, sure. So this is just about done. And okay, so it's finished here. So one of the tools that we talked about was the find tool, which is these binoculars. And this kind of, you can just go around and you can, right here where the seam edge is, you can click that. And what it'll do is it'll bring the piece that is adjoining that to here. And I've got this pretty well set up for 50 inches, which is a little bit too much. So let's just go around 6 inches. So I'll just type in 6 in here and hit enter on my keyboard. And then when I click this piece again, you can see that pretty well matches up to where that has to go. And then we can just go around and select the edges. And as we select an edge, maybe just bring this out a little bit like that. And these pieces here on the side, I believe, go here, and one goes here. And I think that goes there. So if we want, Ian, did you want me to turn on the graphic so we can see how?
Yeah, let's turn on the graphics.
So if I go in here, and I'll just go into render mode, and I go into my highlights, and I'll turn on my highlights, and there you can see the graphic now. And if you want, I can go back into the find tool, and I'll just put it at say 1, hit enter. And then if we go in here and click a piece and zoom in, you can see exactly where these pieces would line up. So you can see that would go exactly where the graphic would lay perfect on any of these pieces.
So when you sew this garment back together, those pattern pieces, the seam edges are going to fit perfectly, but not just the seam edges, also the graphics that have been applied to the pattern pieces. They're gonna flow perfectly across the seam boundaries.
Exactly. So you can see just by lining them up, these pieces would automatically sew together, and there'd be a continuation nonstop of the pattern.
So the real opportunity here is you have transformed the workflow first of all, from a manual process to a digital process, 100% digital from 3D to 2D.
Yeah,
And the second thing is you've enabled now this to be manufactured in a digital process as well using digital textile printers.
exactly. So you can see, and as I highlight on one edge, the red edge, you'll see on the opposite edge, the orange shows up. So I can walk the pattern, and basically, as I walk the pattern, you can see everything's lining up. And I think that's the real key to this type of a technology, especially when it comes to digital printing.
Okay, I'd like to see you change the texture after you flatten it. Now, is that possible?
Yeah, sure. So again, I'll just go in, I'll highlight or rectangle select all the pieces. Actually, what I'm going to do is move this piece out over here a bit, but then we'll just go into wireframe so we can see that everything's selected. So I'll select everything and I'll zoom to extend, and we'll go in and we'll select a different material from our material library. So in this case, we'll just go in, we'll find, say, this paisley pattern. I guess it's called paisley. And I'll hit OK here. And then we'll simply go into our rendered mode. And you can see that the paisley pattern has now been added. Then just
Okay,
as
let's do that again, Mark. Let's just go ahead and change it to another
okay,
pattern. Maybe do the checkerboard one, because that's an easy one for us to see if those checkerboards line up nicely.
yeah, sure. So just go in here. Again, just go into library. We'll find the checkerboard pattern, which I guess is this one here. And as soon as it's applied, I just hit OK, and actually lines everything up. And here, if I just move over a little bit, and we use the fine tool again, I'll zoom in. You can see that these pieces, everything lines up exactly how it would go on the pattern piece.
So you don't even have to re-flatten the garment. Once the texture mapping and the flattening is complete, you can just apply a new texture uh, after it's been flattened, which would save a lot of time.
Exactly. The other thing that we can do is,
And so the output here, let's just
yeah,
actually, I don't want to get too far ahead here. So this has been great. If you can maybe zoom out here so we can see all the pattern pieces,
yeah.
and go back into the mesh view with the numbers associated on each pattern piece.
Okay, so just go into here, up here, our drop down, we go into wireframe. And there's all
Okay,
the
perfect. What
pieces.
I'd like to do
Yeah,
is I would like to measure the surface area of these pieces, because this is really what people want to know. Well, I'd say it's one of the things that people want to know. They have to have confidence that this is a tool they can rely on to accurately and reliably get things done. So let's go ahead, because these are complex pieces, especially piece number 6 and 2 and 3. Those had a lot of undulations in them. The human body is a complex form. For the garment to fit perfectly, it must fit the avatar that it was designed on. It must be sewn together perfectly. And the pattern pieces must retain their fidelity from 3D to 2D. So let's go ahead and measure.
so first what we do, we go into analyze and surface, or actually the mass properties of the area. So if I go in here, then I'll just click the number 6 you said,
Yep.
and just hit enter on my keyboard. And we have the area of 1,415 0.49299 square millimeters.
Okay.
And then if we go back, if I go into my layers and I go make this layer active, and sorry, turn off that layer, and we'll just go into the model view in perspective, and we'll find number 6, which is this piece here, I believe.
That's correct, yes.
So what we'll do is we'll do the same thing. We'll just go into Analyze, into Mass Properties, Area, and we'll select this and hit enter on our keyboard, and we get 1,413.37094.
Okay, so the 2D measurement was 1,115 square millimeters,
Yeah,
and the 3D measurement was 1,413 square millimeters. So we have a variance of approximately 2 square millimeters, which I would say is more accurate than any manual pattern making process could hope to be.
oh yeah,
This is
absolutely.
essentially perfect from a manufacturing perspective.
Exactly.
Okay, let's go again to another piece. Let's just do this one more time. Let's take pattern piece number 2.
Okay, so I believe this is number 2 here.
Yep.
So if we go in, Analyze, Mass Properties, again, sorry, analyze the mass properties of the area. Number 2, we get 3,260.09.
Okay.
And then if we go back into our pattern view, turn off our other 2 views. We'll go on the top. Now we'll zoom to extend. So number 2 is right here. So again, we go into Analyze, go into Mass Properties, go into Area, select number 2, hit enter on a keyboard. So we have 3260.35.
So in 2D we had, or pardon me, in 3D we had 3260.09, and in 2D we have 3260.35. So that's perfect.
Yep.
That's a perfect fit. There is no difference from a manufacturing perspective. In fact, the width of the cutting blade could not make this more accurate. You are off
Exactly.
by, less than 0.2 or approximately 0.2 square millimeters on 3,000 millimeters.
Exactly.
So I would say that's a result that would certainly give people confidence that the patterns generated are going to be accurate. Now, apparel is complex. People's bodies are complex. These are complex forms, but we've just demonstrated accuracy. And particularly with that pattern piece number 6, which has a fairly deep dart and relief cut into it.
Yep.
Let's highlight that relief cut. And despite that, the geometry is only off by 2 square millimeters on 1,415 square millimeters.
Pretty incredible.
It's amazing. And so I know that you have led the team to create the software over many, many, many years. So congratulations for putting together a very good piece of technology here. Now, where do we go from here? So now we've got our flat pattern pieces and we've got our graphics on them.
Yeah.
I suppose we'll leave for another day the actual manufacturing and showing how this dress fits.
Sure. Absolutely. So once we get to this point, though, to export it out to the Reggiani printer, we have 2 ways that we can get the file out. We can either create a PDF that has the raster and the vector information, so the cut and the print information, or we can create a TIFF and a DXF file, or a variety of other graphic files, depending on how your system works or what you're looking to do.
Okay, so this would be the next step in the process is rendering out a file. You would then put that onto, send the output to a digital textile printer like an EFI Reggiani printer.
Yes.
It would print these designs.
Yes.
Then it would go to a cutter, which would cut these contours.
Yes.
And then it would be sewn together and put on the fit model for further design review. Or if it's already approved, it goes to the customer.
Exactly. That's good.
Well, thank you, Mark. That was a fantastic demonstration. And I think that a lot of people will find it valuable. There's a new way to create your products using 100% digital processes. If you have not yet made the decision to start experimenting or make the transformation to 3D, make the transformation to digital, make the transformation to ExactFlat, and make the transformation to digital textile printers such as EFI Reggiani printers. now is the time to do so. We think that this technology will give fashion designers a bigger palette with which they can create compelling, inspirational, beautiful, functional clothing designs. And it'll give manufacturers a much faster, more flexible way of bringing their products to market. And it'll give customers a much wider variation of products they can choose, and perhaps they themselves can be the architects and customizers of their own clothing. Mark, if there's nothing else to say, I'll like to thank you for your time.
Yeah, no, that sounds great. Thank you very much, Eaton. Appreciate your commentary.
And what we'll do is we will, in the next part of the series, we'll show these patterns being print and cut and final garments put on people. All right, Mark, we'll wrap it up there. Thanks a lot.
Yeah, thank you.
Okay, take care. Bye-bye.
Bye.